In the AP exam, you will often see questions in the free response section say, explain the meaning of your answer in the context of the problem. So when you see this phrase, what it's really looking for is essentially three things. Number one, you're being able to express the correct units, either the units of the derivative as a rate or the units of the area under the curve. If you're stating rate, you need to state the whether it's increasing or decreasing. If you're stating a quantity, you have to state whether that quantity increased or decreased. And thirdly, what they're looking for is a specific time for the derivative. So if you're saying that it has a rate of x, you need to state it happens at time equals y. For the integral, you need to state the specific time interval. Okay, for the area or displacement, you need to state that this area or displacement occurs between x equals, time equals 5 minutes to time equals 10 minutes. Okay, so those are the three main things that you're being asked to explain when you're being asked to explain your answer and the meaning of your answer in the context of a problem. So we'll do a couple examples here to show how we can explain the meaning in context. So it says here we have oil is leaking from a pipeline on a lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. And the oil slick takes the form of a right circular cylinder, and the volume of that cylinder is given by the volume of the cylinder formula. At the instant that when the radius is 100 centimeters and the height is 0.5 centimeters, the radius is increasing at a rate of 0.5 centimeters per minute. At this instant, what is the rate of change of the height of the oil slick with respect to time? So first of all, we need to generate the dH by dt. Okay, and we've been given in this case, this is going to be the dr by dt. And we've also been given here the dv by dt. Okay, so this is a related rate problem. And again, with related rate problems, we need to be able to connect the variables in question. In this case, we've been given the formula to connect them. We need to differentiate this implicitly and then fill in the known parts to solve for the unknown parts. So here we're going to we need to find dH by dt. So we're going to differentiate the volume formula implicitly. So we're going to differentiate V with T. The R and H are variables, so we need to use the product rule to differentiate that. So we end up with 2R times dr by dt times H plus r squared, and times dH by dt. Okay, so there is our expression. We need to then solve for this. Okay, so we're just going to plug in all the unknown parts. So the dV by dt was given as at the initial, so 2,000 centimeters cubed per minute. Pi, the radius is 100 centimeters, so we're going to go 2 times 100. dr by dt, we've been given as 2.5 centimeters per minute. And the height we've been given as 0.05 plus r squared is going to be 100 squared times the unknown part dH by dt. Okay, so then we just rearrange all this. So doing the algebra here, we end up with dH by dt. Okay, it's going to be what's that going to be here? So we're going to do 2,000 minus that's 200, 500, 250 it looks like, 250 pi, so minus 250 pi divided by, looks like 10,000 here, 100 squared, so 10,000. Okay, and I end up with dH by dt is going to be 0.1214, so I'm just going to round that to 121. Okay, so now if I were to interpret this in context, I need to give the units of this dH by dt. So it is going to be in centimeters per minute. Okay, this is increasing by 0.121 centimeters per minute. And thirdly, we need to say it's at time equals, in this case, it doesn't give us the actual time, but at some specific point. And we can say that at the specific point it gave us was when the radius is 100 centimeters, or we could also say that it's when the height is 0.5 centimeters. So at r equals 100 centimeters and h equals 0.5 centimeters. Okay, so if we want full marks, we need to again know that this is happening at a specific point. It's increasing, and also the rate, the units of that rate.